Hi, this is Mr. West, and this is a worksheet tutorial video for squares and square roots. This, of course, is from mathdrills.com. Make sure to check out Math Drills in the link below. They have amazing math resources. So what is this? Well, we have two different sections here, and we're actually going to start with the bottom section. It's these numbers here with a little number up in the right corner and then a bigger number off to the left. So what does this mean? Well, I'm going to first describe that this is what we call a base, and then this is called the exponent. And that exponent does something, and I'm going to describe what it does in a picture below, starting with that 3 and the 2. So what does that mean? Well, first off, you can read this as 3 to the power of 2. Okay, so that's 3 to the power of 2, or because it's a 2, we can call that 3 squared. Okay, so I just wanted to clarify the terminology. That's 3 squared. But why is it squared? What does it have anything to do with the shape? Down here, I have a shape. And if I draw a square, and it's probably not exact, but you'll get my meaning. And if I draw a square with sides of 3, so if I have that 3 units and that side 3 units, what I can do is I can draw some lines here to designate that they have 3 and 3. And what we're going to do here is if we are trying to find the area of this square, we are going to multiply 3 times 3. I didn't do a perfect job here, but you can see if I multiply 3 times 3, I'm going to get 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 units squared will be the area. If you've ever done geometry before, you'll notice that they talk about square units, and this is why. Because you multiply 2 units together, and so you multiply the units by themselves twice. It's the same thing here. 3 squared, which we just showed, is we showed it with 2 sides of side 3. And to find the area, you multiply the 2 sides together. 3 times 3 equals 9. So that is what 3 squared means. 3 times 3 equals 9. This little exponent tells us to multiply 3, the base, by itself 2 times, and that equals 9, and that's our answer. So all of these we can just rewrite in expanded form like this. 4 is going to be 4 times 4, which I know is 16. 5 is going to be 5 times 5, which I know is 25, and so on. Now let's go up to the top section. I'll give you guys a chance maybe later to try off that bottom section, and I'll do a couple more hard ones before I leave. This blue one right here is called the square root. So this is called the square root. Just think of square root as the opposite of what you just did. Okay, so before we were taking the number and then we are multiplying by itself. Now we're going in reverse. So we don't know these side lengths, okay, but we do know that inside we have an area, if I may, of 16 square units. So what I'm going to do here is I'm just going to draw a shape with this, not a shape, a square with 16 square units on the inside. Okay, so let's just say that this has 16 perfectly drawn square units on the inside, but we don't know what two numbers multiplied together gave us 16. Or I should say, what number multiplied by itself equals 16. So what we need to decide here is, what do I multiply on the left side? So we have 1, 2, 3, 4 units over here. So instead of a question mark, I'm going to put 4. And then this side, 1, 2, 3, 4. If you have a perfect square, you'll have a number that will multiply by itself to equal this number. So what is the square root? The square root is 4. 4 times itself twice equals 16. So we can go forward and backwards. We can go 4 squared equals 16, and then we can say the square root of 16 equals 4. That's how we go forward and backwards in math, and the square root is just the inverse of squaring something. All right, let's do another one. So we have square root of 64. We're thinking to ourselves, what number times itself twice equals 64? Well, we could refer to our times tables. Okay, so if you have a multiplication chart, you'll notice that as you have the numbers on the top, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, that all the perfect squares are going to be in a diagonal because that's all the numbers that are multiplied by themselves. And so you can check here the multiplication chart and you'll see that 64 will be located right there. And so our answer is 8. Why? Because 8 times 8 will equal 64. And that's how that works. Now I want to show you something real quick. Numbers that are not perfect square, because not every number is a perfect square. So if you were to try to do this with 8 units squared on the inside, is it possible? Not with integers, okay? Not with whole numbers, because there's no number multiplied by itself that's an integer that will get you 8. You can't draw units perfectly to get 8 units squared, so therefore this is not a perfect square. There's no number times itself that equals 8. And I can show you another reason why that is. If you do 2 times 2, you get 4. 3 times 3 equals 9. Notice how we already skipped over it and we went from 2 to 3. There's no number in between 2 to 3, therefore 8 is not a perfect square. Let's do a couple more tough ones. So if we have something like 11 and you don't have a multiplication chart, you don't have a calculator handy, you can just use a standard algorithm. So we're going to stack it. We're just going to do the first column. One's columns first. 1 times 1 is 1. And then we go on to this column with this number. Okay, actually, let me change. I'm going to color code this. I've done this before in other videos if you want to check those out. But I'm just going to do that number first, the ones place. So do 1 times 1 is 1. 1 times 1 is 1. I'm moving on to the tens place. So let me change colors for that. I'm going to do purple now. Okay, so now I have the tens place. And I need to drop a 0 down because I am in the tens place. And then I do 1 times 1. And then the other 1 times 1. So I have 1, 2, 1. 121 is 11 squared. It's a little tougher going backwards with this one. There's not like a procedure you can do other than trying to find numbers that multiply by themselves to equal this. For example, 225 is going to be 15. I would suggest a multiplication chart for that one and some of the ones that you don't know. That's going to be a very useful tool for you. So I hope you guys enjoyed this video. Make sure to leave a comment if you need help on it, and I look forward to seeing you next time right here on Wes Explains Best.